Yeah, good afternoon, everyone. So we had a quick lecture on Pigeon Ruby on last Thursday, and so the intent of that lecture was to go through kind of the most basic things that Ruby has to offer, so that when you see them in the Rails code today, that you can kind of read along. There's a few changes that I'm going to ask you to make, but you should be able to do those just by sheer imitation. Today we want to have a look at Rails so that you can see, that poster child of adaptability and flexibility. And on Thursday we're going to make a deep dive into the features of Ruby that make this possible. Even after the end of Thursday, you will not don't put on your resume that you know Ruby. You know, like the very simplest thing, and you will know the most complicated parts of Ruby at the end of Thursday, but nothing in between. And that's just life. We're not interested in churning out yet another set of Ruby programmers, but we want to be able to understand this one particular feature set of a programming language that lets it do these kind of amazing things. So today we're going to run through this Rails tutorial, and it's pretty much going to be kind of follow along what the basic tutorial says. And then I want to ask some probing questions where hopefully you will be able to get a glimpse for what goes on under the hood. And then on Thursday, we're going to talk about it more deeply. So you will not be a competent Rails programmer after today, but you will have seen it with your own eyes, and you'll get a little bit of a feel as to what it is and why people like it. So the things that you're going to be seeing today are this convention over configuration thing, where there's one place where you're supposed to be doing things, and you don't have a lot of choice. You follow the convention, and good things will happen. And you just kind of have to learn what the conventions are. In the tutorial, of course, they tell you, go here, go there, do this, do that. And you just kind of follow it along and trust that it's going to be good for you. You're going to be experiencing this don't repeat yourself, where when you need to make a change, you don't have to say 3 or 4 times in different places and in different languages or configurations what it is that you want to achieve. You just put it in one place and everything just happens. You're going to be seeing this active record thing, and that's probably the most interesting part of Rails from a programming language perspective, where it dynamically, it looks into the database and it finds stuff in the database, and then it turns it dynamically into classes. You don't have to write those classes. And it's not like a code generator thing. It's not it's not where you kind of have your IDE look at it, but it's a very dynamic process. And we're going to be seeing just a little bit of the infrastructure, not very much. So just the basics of web development. I don't know how many of you have really done a lot of it. So every web page access kind of starts out with a GET request. The client is the browser. So the browser sends a GET command to the web server using HTTP. So here's a typical HTTP command. This GET, and it gets some stuff. And then it might have other request attributes, which this one here, that doesn't need. The browser then gets a bunch of HTML back. So when you make an HTTP request, you get HTML back. The browser renders the HTML, and the rendering means it'll make pictures, it'll make bullet lists, and hyperlinks, all of that good stuff. And of course, in the web applications that we're interested in, there may also be form elements, in which case the browser will render the input fields, the buttons, and so on. Now, then the user fills out the form and clicks on the submit button, and what the user typed in now gets sent back as a post request. So we'll have the verb post. It'll have a particular content type that called URL encoded, and you'll see in a minute why. It'll then have the content length, might have a bunch of other attributes, and then it has whatever things were in the form. This form had a field with an ID username and a field with the ID message. The user put in Fred1729 as the username and hey you as the message. All of that gets munched together in this URL encoding, which means attribute equals value, ampersand, attribute equals value, and so on. And inside the attributes and values, if you have non-ASCII character, they get encoded in brain-dead way number 97, namely by putting a percent and then putting them in hexadecimal. So that's URL encoding in a nutshell. And that gets to the server. The server reads the string and now has to figure out what to do with it. And so a challenge in writing a web application is, of course, that now the server gets the stuff. It now needs to spring into action. It needs to remember, what was that form that I sent this fellow? And then has to figure out what's the next step, and and then has to render more HTML. You have this phenomenon of what's called inversion of control, that from the point of view of the web application, it's not a continuous flow of control, but you get these commands in bits and pieces. And each time you have to remember where you were at. This is always a painful thing to deal with, and we're going to be talking about how this is done in another programming language with Schema, Racket, using continuations, where it has a much more elegant web programming model. Ruby doesn't have that. It does kind of the same thing as most traditional web frameworks. So it's a challenge in web development that every page must be re-rendered. You have to just write this fairly tedious and repetitive code for page rendering. Flow control is really unintuitive. So it's HTTP is a stateless protocol that by default there's no state is kept, and you can keep state with things like cookies, but it's work. There's the infamous thing of the back button that you know from your own browsing experience, that half the time you hit the back button and it doesn't really get you back. It's the expectation of the user that it kind of goes back in time, but it's entirely possible, like it happened to me many times when shopping, that I wanted to go back, I went back, and then my shopping cart was empty, or it had everything twice, or weird things started happening. And the other thing is, of course, that performance tends to be bad. So so web development is hard, and every bit that one can do to make it easier helps. So one of the things that helps is to put some structure into what goes on the server. And so the classic model that people like to use is the model view controller framework, where we want to differentiate between different pieces of functionality on the server. The model in this particular, in the case of a web application, is some kind of data that a program manipulates. So the shopping cart is like the classic example of what's a model. The shopping cart is a list of goodies that someone wants to buy. And it's a class that contains a list of items. That's really all it contains. What else is a shopping cart? That's maybe also the name and address of the customer, but that might be a different object. So it has no visual representation whatsoever. One can paint it in some way, but by itself, the shopping cart is just the items. It may be persistent, and one would kind of hope, in fact, that it is persistent, so that if you log out or just time out and then you come back later, it would be kind of nice if your shopping cart was not lost. So that means that the shopping cart needs to end up in some database. And but the point is, it's not a visual thing at all. It's just as an abstract entity. Then you have what's called a view. In the view is the code that renders how something looks like. That would be the code that paints the shopping cart, that paints all the other artifacts that you have on your web page. And one characteristic of the view is that it will read the model data. The view will read the shopping cart. It will read your login information, but it never modifies it. And then you have the piece that interacts with the user, that gets the user commands, and that then modifies the models. That's called the control. So here, in this hard-to-see diagram, one can see that the model is queried by the view, and it is updated by the controller, and that the view itself takes no user input at all, but the controller will maybe build a new view, or in an AJAX environment modify the view, and of course it'll access the model to effect mutation. So that's a framework that tends to be a good way of organizing one's thoughts in a web application, and that's very popular. And Ruby uses that. In fact, Ruby really enforces it by making you think about every time that you do something, is it a part of the view, is it a part of the controller, is it a part of the model? All right, so in Rails, we have this object relational mapper called ActiveRecord. And an object relational mapper is a nowadays common technology that bridges what a database has versus what the application has. In an object-oriented development, you deal with objects. You deal with an object invoice or shopping cart or a customer. Your database has tables. And it's not a one-on-one relationship. If you think of a shopping cart, the shopping cart has a list of items. Now, the way you do that in a database is you have one table for shopping cart, you have another table for items, and you have a one-to-many relationship between the two. And then you need to make a select query when you actually want to retrieve a shopping cart that you select over all of the items that belong to it. And then you would need to assemble all of that into an object so that one can manipulate it in an object-oriented way. Or some programmers don't actually go the object route. They instead write their programs in terms of rows of a database, but that makes the program harder to deal with, because then if you want to give something to another layer, for example, it's easy to give someone another object, but it's not so easy to give someone a mess of unstructured stuff. Generally nowadays one wants to have this translation from what's in the database to the objects that a program manipulates. So these OR mappers do that. In the world of Java, you would use JPA. One day I'll figure out why this is important. Or Hibernate. They do the same thing. You, the programmer, you worry about objects, and the SQL queries get done behind the scene. And so it's probably a fair statement that in this day and age, you probably should not be writing raw SQL anymore. So in the database class, they still teach you how to do SQL, but that's either because they're 10 years behind the times or because they want to aid you in debugging what the OR mapper might do wrong or inefficiently. But usually these OR mappers have become very, very good. They generally write better SQL than most human programmers. They do all the caching that you would be hard-pressed to do on your own. And so one just tends to rely on these. All right. So as an example, let's say that in the database we have a table that has 3 columns, name, string, and content. Well, I should point out that in ActiveRecord, one first builds the database, and then it infers the objects from the database. That's the exact opposite as with JPA and Hibernate. In JPA and Hibernate, you first build your object model, and then you leave it to the OR mapper to create the matching tables from the database. Personally, I think that's a saner approach, because as a programmer, you care about your object model. You want to implement objects, and the fact that it all has to be put in a database, that's some kind of subordinate thing. And but people who are database people, of course, believe that the database is the most important thing in the world. And they're wrong, but they often hold a lot of power. So the Rails people, they say, we're not going to fight that. We're just going to suck out whatever is in the database and turn it on. So let's say we have a table that has columns, name, string, and content that contains, in this case, posts in some discussion group. So you make a class post. The less than sign means it's a subclass. It just means extends. And it's a subclass of ActiveRecord base. And we don't put any data in here. Notice there's no instance variable declarations. This is end. So nice, so peaceful. End. So that is the entire class declaration. What ActiveRecord base does, as we'll see on Thursday, is it now springs into action. It says, oh, my subclass has no data in it. It then goes to the database, makes a query to find out that the table named posts has these 3 columns, and then it makes a field for each of those. So this is a very dynamic language where one can add fields programmatically. It doesn't have to be declared and then compiled. But as the program runs, the class can acquire new fields. And a superclass gets notified every time that someone subclasses it. So good old active record base sits there slumbering, but once in a while it's told, hey, someone is subclassing you. And in that case says, oh, that poor sucker doesn't have all of its instance variables. It then goes to the database, looks up what instance variables the subclass should be having, and injects them dynamically. There's no way you could do anything like that in Java, of course. Because in Java, you have to compile before the program runs. You can't add classes dynamically. But in Ruby, you can. So notice that in the convention configuration kind of thing, that the tables always have to be named with plurals, posts. But the class name is the singular. So it adds an S, or subtracts the S, which sounds kind of going beyond the Call of Duty. And it's, of course, fragile as heck, because when the plural form is irregular, Rails knows a finite number of irregular plural forms, and so hopefully knows the ones that you're using. So notice here we're now making a new post, and we say p.title equals learning Rails is fun. And so the title field at this point has sprung into existence. All right. Now, if you want to establish a relationship, then you do have to do that in the class, because there's not enough knowledge in the database tables to do that. So here, if I also have a user class over here, and so I have a user table, I have a post table, both of these use the active record OR mapper. Then I put these relationships in here. Belongs to a user tells the mapper to look for a column whose name is user ID. So it has to be the name of the field followed by an underscore ID. And then it'll make an instance variable called user, I guess, that lets us access the user of a post. And conversely, over here, we say that a user has one or more posts. In this case, the OR mapper is going to make a collection valued field posts, so that when you have a user object, it automatically sucks out all of the posts that may be there by just making a select query. And it builds these things on the fly. All right, so that's the OR mapper. There's more to it, of course. I gave you a link to the 20 other things that you can do with it. But that's the basic idea behind it. They give you yet another way of mixing code and HTML. That's called ERB. And it's pretty self-explanatory. It works just like JSP or PHP or any of these things that you've seen. So you have plain old HTML, and then you have this delimiter with the % here that can contain Ruby code. So over here, what we're doing is we're painting a table. You see that we're having a table, and then we're iterating over table rows, and these are just done laboriously by hand. So the at posts, notice that at is to reference an instance variable. All instance variables have an at in front of them. Posts.each, you remember what that thing does. It's just like for each in Scala. Then we have a do, and somewhere there must be an end. Okay. The do end then loops over each of them. This vertical bar thing here, remember that's the parameter. And then inside here, it's just going to then generate this thing here for each iteration in the loop. And over here, it injects in it the name of the post, the title, and so on. And now I don't know whether there should have been @ signs here or not. Oh no, I guess these are methods. These are methods, not instance variables. So that's fine. And, yeah?
You said at refers to the instance variable.
Yeah.
So So that refers to the instance variable of the class.
Yes.
The class was just post.
No. This post is put into a view class. So there is a view class that has a reference to the current posts. We'll see that in the lab and how exactly it gets in there. You have to put it in there. Yeah.
I think our question was the class name was singular.
Oh no. This is the name of a field. And the convention is, for whatever reason, and I actually called that out here, that if you have a has-many relationship, you must name it with a plural. Because a user can have many posts. But the question that I thought you asked, which was a good question, was that this must be an instance variable of something. And it's an instance variable of the view class, that of one of the many view classes. There is a class for every HTML page that you might want to paint. And it must, of course, have the instance variables for the model objects that it's painting. And you're going to put them in there. You'll see. All right, so as a practical matter, there's lots of frameworks out there that make you do this kind of stuff. And the danger is that you get a horrible spaghetti of code and HTML, and it might be hard to do visual improvements on this thing. So the other technologies, if you're familiar with JSF, for example, where they separate these things much more cleanly, where you have a component model and the components do all of the painting, and the programmer would never do this kind of low-level looping. But that's not what Rails is about. So in Rails, you do the quick and dirty looping, just like you would do in PHP. All right, finally, the controller has a number of different aspects. There's a little mini language or domain-specific language for routing. So where it says that when you get an action, the root action, that then you should show the page that's under the home, that's inside the index category of the home category. And we're not really going to have the time to go through this in great detail. I say it's a mini DSL because actually when you look at this thing here, this thing to the left is a method call, and this thing here is an argument that's actually a hash table. So it makes this hash table on the fly, and then there are parentheses that are put inside here. So it uses Ruby as the syntax, but it kind of abuses it to make it look somewhat nice for human eyes. And this is a common thing when you have these Ruby DSLs that they try to take advantage of, that you can omit parentheses, for example, to make it look more natural, and that the arrow automatically makes these hash tables that the arrow looks kind of visually pleasing. So this is actual Ruby code, but it's they rig the functions to make this particular routing language. All right, and now over here, the controller also needs to gather all of the posts, and then it needs to implement this respond to function where, and that's kind of some boilerplate thing. I don't know why one actually has to do this. Depending on whether you're supposed to render an HTML or XML, you need to do some stuff. So here, you say if it's an HTML, then one looks this ERB file here, and otherwise, there's some other mumbo jumbo. Much of this gets generated automatically, and we don't really have to look at it. Now, when you make a Ruby application from scratch, when you have a few tables, you point Ruby to those tables, and then you say, now go ahead and make an application. Then, of course, it can't do anything for you with shopping carts or with a dating site or something. But the application that it builds for you is a very simple one that lets you read data from the database, put new data in there, or delete stuff in the database. So it's what's called a CRUD application from those fundamental operations: create, read, update, and destroy. And so it just makes this application. And so the belief is that that's a good basis for customizing the UI. If you have an application that lets you edit the tables, add new things into the tables. That's not all bad. And one advantage is certainly because you're given the source code to that application, you can learn a bit of Ruby and Rails by looking at that source code. As a practical matter, I have never found this useful because the applications that I write really are not CRUD applications. I mean, they're not letting any arbitrary user make arbitrary changes in a database with a hard-to-understand table interface. But people find it very satisfying somehow that you just type a few lines of code and presto you have something that would be really tedious to write by hand, whether or not it's useful. So you're going to see that. Finally, a bit on REST. So Ruby tries to be reasonably RESTful. Restfulness means a few things. Basically, REST is an architecture for architecting web applications that so that they can cache well, that they work well with the standard caching infrastructure. And so when talking about resources, and so things that you might want to request that should just give you a list of stuff, they have some global identifier. In the case of Rails, they might look like this, where you have your application, and then you say you want to look at posts, and now I want to look at the post number 1729. And then you get the post out of that. So instead of having, like the anti-REST is what you get when you go to Amazon, where when you look at a bookmark, and it has these random letters that are there from your session state. Because that if you bookmark that and you went back to that, it wouldn't mean the same thing again. But that's of course only when you put things into your cart. Amazon does have a RESTful part when you look at a book, for example. That URL is RESTful. When you issue it again, you're going to look at the same book again. And REST doesn't, the resources, they can mutate. When you look at a book in Amazon and you look at it again a few days later, what you get may be different. You might have more user reviews, for example, but it's still fundamentally the same resource. So here it says get should be item potent, so that when you issue the same request, you get the same data. Well, you get the same description about whatever it is that you want. It doesn't have to be exactly the same data. But it does mean that the resource can be cached. So if you went to Amazon and you wanted to look at some book and you got the description from 2 days ago, that would be okay. So what? You didn't get all the latest reviews, but you got almost all the latest reviews. So if the cache description said it's okay to cache this page for a week, then the cache can get you an older one. So that caching makes it more efficient. And so the idea of REST is that you issue commands using HTTP to the server that use get, put, and delete for the obvious semantics, and then post for kind of everything. And so Rails uses that throughout. All right, so the only way to make progress here is to actually experience this. So it's going to go through this, and I'm going to go through it with you because I've forgotten half of it again. And so we'll follow along this lab. I did check yesterday that the steps have not changed from since I last did this, because that would be embarrassing. And so the point of this is to kind of look around and to get a basic feel for what you can do with it. And there's one step that I'll call out to you in about 15 minutes where you can do something interesting with the console. That'll make you appreciate the integration. All right, so let's go ahead with the lab. Do we have an even number of people today? Yes, we do. No, we don't. Oh, you don't have a buddy? Oh, that's bad. He needs a buddy. And why don't you read it?